Hello everyone, welcome back to Econ News. I am Jinhua. Today we're going to talk about big news. TSMC, the high-first of semiconductor, had built new fabs in several places around the world. First, let's talk about how TSMC makes profit, especially since it holds a near monopoly position in the advanced semiconductor industry. This is the standard monopoly diagram. The firm determines its profit maximizing quantity at the point where the marginal cost curve intersects the marginal revenue curve. After choosing this quantity, the monopolist then charges the highest price consumers are willing to pay, which is found on the demand curve directly above that quantity. According to the graph, the monopoly price is P and the monopoly quantity is Q. The profit is the area of the orange rectangle, calculated as P minus ATC multiply quantity. To deepen our understanding, let's make some changes to the diagram. First, compared with perfect competition, the monopoly market creates deadweight loss, shown as the gray triangle. The reason is that unlike a free market, which produce at the socially efficient equilibrium, the monopolist restricts output to the profit maximizing level. Next, let's discuss how real-world factors like the surge in AI chip demand from companies such as NVIDIA and OpenAI shift the demand curve and affect price and output. When demand increases, the demand curve shifts outward from D to D plumb. Even though demand rises, a monopolist is a price maker, so it raises the price from P to P plumb while keeping the outputs the same. This reflects the monopolist's incentive to maximize profit, not social efficiency. Next, let's take a deeper look into TSMC's cost structure. There are two types of cost: fixed cost and variable cost. Fixed costs include factories, equipment, land, and long-term skilled labor, costs that do not change with output. Variable costs include raw materials, electricity, water, chemicals, hourly technicians, and maintenance that depends on production volume. Now that we've discussed these high fixed costs, let's consider how high fixed costs and economies of scale reinforce TSMC's natural monopoly characteristics. TSMC's fixed cost fabs, extreme ultraviolet machines, and R&D can cost tens of billions of dollars. This makes market entry extremely expensive. As for economies of scale, once TSMC has already built those multi-billion-dollar fabs, the average cost per chip becomes lower as output increases. This is because the huge fixed costs are spread over a very large number of chips, and production becomes more efficient at high volume. Return to the monopoly graph. As we mentioned earlier, economic profit is shown by the orange rectangle. The key is the average total cost curve because of TSMC's massive scale and high yield. high yields. Its ATC curve is extremely low. The vertical distance between the price P and the ATC forms a large supernormal profit rectangle. In perfect competition, such profits would attract new firms, reducing price and eliminating excess profits. But here, the barriers to entry, such as a 20 billion fab, are so high that new competitors cannot easily enter. This protects TSMC's profits in the long run. This brings us to our next point. TSMC has recently built new fabs in Arizona, Kumamoto, and Dresden. So, are these long-run decisions or short-run decisions? They are long-run decisions. In the short run, at least one input, such as capitals, factories, or major equipment, is fixed. But in the long run, all inputs are variable. Building a new fabs abroad requires purchasing new land, constructing new facilities, and installing new machinery. So these are clearly long-run choices. Moreover, high fixed costs shape TSMC's decisions in several ways. They force TSMC to plan for the long run very carefully. Economies of scale only occur at extremely large outputs, which encourages TSMC to continue expanding. Last, high fixed costs discourage new entrants, reinforcing TSMC's natural monopoly-like structure. Finally, if Intel, Samsung are able to produce 2 to 3 nanometer chips in the future, what would the impact be on TSMC? When only one firm exists in the market, like TSMC today, we call this structure a monopoly. A monopoly sets the highest price, the lowest output, and has the strongest market power. But if more than one firm competes, the market becomes an oligopoly. In an oligopoly, prices fall, output increases, and market power weakens. TSMC would still be a major player, but it would no longer have near monopoly influence over the most advanced process nodes.
And this is for today's news. I'm Jinhua. See you next time.